First of all, LTE, as everybody knows, taking off in a much more profound and practical way with real deployments. So not only in North America with AT&T and Verizon, but obviously in Germany with the 800 megahertz band, in Japan obviously with Docomo and others deploying LTE. So LTE is becoming a reality both for the FDD and TDD mode, so we're very enthusiastic about both opportunities. But obviously the other technologies are not going to go away soon either. CDMA will be there for a long time, both the 1X RTT and DO variants. We'll see GSM Edge for a long time. And fundamentally, we think the best way forward to support LTE, FDD, and TDD deployments is to build them into a superbly well-crafted solution that can handle both the legacy technologies and HSPA Plus and LTE going forward. So our first fundamental concern was being able to handle LTE correctly. And by correctly, I mean transport the core waveform at a very high signal-to-noise ratio so that we try to enable both MIMO streams. We can do so successfully without any interference from the base station from our DAS transfer site to that would prevent the full realization of the fundamental capacity of the air interface. And we say that especially because we're very aware of the use of TE systems on an indoor basis, where signal-to-noise ratios tend to be very high. We can use the channel quality feedback from the device to enable the second MIMO stream and get to very high throughputs, which is ultimately what we believe LTE is about. And I spent a lot of time working through LTE standards. I participated in great detail in the Release 8, Release 9, Release 10 specification work for LTE, as well as specifying the HSPA core specs. So I was very interested in seeing how we could reduce some of those core specifications to practice and get back into some of my roots, which was in base station implementation and device implementation. So I wanted to get away from the theoretical physics for a while and do some more practical stuff.